I've had some questions about 9b on the AP Focus packet, so I thought we'd take a look at this. They give you the graph of f prime, and they are asking you to find the value of f of negative 6 if f of 2 is equal to 6. Okay, so we're starting out with f of 2 equal to 6. We have f prime, so we know we're going to be taking the integral of f prime to get back information about f. And we should love this problem because, look, we've got areas of things that are very easy to find. Integrals are areas, right? And we've got triangles, and we've got a half circle there. This is fantastic. So remember, the idea of the accumulating function is that you can take the integral of a derivative over an interval, and it will basically tell you the change that occurred in the original function over that interval from whatever your initial position is. So we're going from 2. Now, here's the challenge. We're going from an x value of 2 back to an x value of negative 6. Okay, so remember, you're always starting out at your initial value. So you're starting out at 6, and we're going to be taking the integral from 2 back to negative 6 of that derivative function. Okay, so the bounds are backwards from what we're used to doing. We're used to saying negative 6 to 2. Okay, what that means is that derivative or that integral is going to read backwards. Okay, basically anything that's positive will be negative, and anything that's negative is going to be positive. Okay, now I'm also noticing that there's some really basic shapes here. Between 2 and negative 2, we've got a half circle. So I'm thinking, why don't we break this integral up? We've got our initial value. We've got um, we've got our initial value. We've got an integral going from 2 back to negative 2 of the derivative. And then we've got an integral going from negative 2 back to negative 6. And if we do it that way, then we've got a half circle and we've got a triangle. Okay, the area of the half circle, it's a radius of 2, so 4 pi would be the whole circle. That's a 2 pi, that circle there. Okay, and the area of that triangle, that's a 2 by 4 triangle. So the area of that triangle should end up being 4, right? So those are our integral values, okay? Now, here's the key, though. I want to change the order of my bounds. And to change the order of my bounds, I'm going to have to switch my signs. So I'm going to do 6 minus the integral from negative 2 to positive 2 of the derivative of f. And I'm going to switch this sign and do minus the integral from negative 6 up to negative 2 of f prime, okay? And then we just have to put it all together. So we've got 6. It's going to be minus this integral here. That's a half circle. So it's minus negative 2 pi, which of course is going to turn into plus 2 pi. And then this last integral back here, that triangle area, is going to be 4. So it's going to be minus 4. All right. So if we put all this together, we've got 6 minus 4, which is 2, minus a negative 2 pi ends up being plus 2 pi. Okay, so looks like it's going to be option A. Again, it's a little bit tricky because you're moving backwards. So because you're moving backwards from 2 back to negative 6, all your dx's, all your widths of your rectangles, if you were doing Riemann sum, would be negative. And so what's going to happen is, because you're moving backwards, all of your negative area regions are going to read as positives, and all your positive area regions are going to work as negatives. So some people like to just kind of think backwards through it. Some people like to actually go through and change the order of the limits and flip the signs. But I love these problems. You don't get AP credit very often for finding areas of half circles and triangles. So these are really nice problems, and I would love it if they asked stuff like this on the AP exam. That would be fantastic. Hope that helped.